So just to make sure that you still can hear my voice clearly and see the exam paper, right?
Yeah.
Okay, fine. I think we were discussing before about the first page or the cover page, which was written here, paper 6, alternative to practical. It's not a real practical because you are not requesting to do any experiment. We did the experiment for you, and you just need to do some measurements and some comments. You need to write it. There is no choices here. You need to solve all questions as written in the paper, answer all questions, and use black or dark blue pen. You're not allowed to use pencil unless if you draw a graph or draw some figures or diagrams. Make sure that your name is written correct and the center number and the candidate number in the boxes of the top of the page, unless if someone did that for you. And sometimes some centers, the invigilators should write that for you. It depends on the center. Write your answer in each question in the space provided. This is a mistake. We said that before. If you answer in somewhere else in the paper, the examiner will be not allowed to see that. So the best idea is to write in the only space provided. Yes? We said that before. This is a mistake. No one will see it. Sorry? ما فيش examiner انت شفته خالص. انا بقالي 3 شهور بحاول اخد ميعاد من examiner عشان اعمل له انترفيو على اليوتيوب، وهنعمل له قبل بيبر 4 next week. بقالي 3 شهور بحاول اخد ميعاد. examiner مين اللي قال لك يا حبيبي؟ واقف عليك. الاكزامينرز دول عايشين في انجلترا يا بابا، واقف عليك ازاي؟ انت رحت امتحنت هناك؟ سيف حبيب قلبي، اسمه انفيجيليتور، مراقب. المراقب ده ممكن يكون مدرس تربيه فنيه. والله اللي يعجبك، اللي يعجبك. الموضوع ده ما تكلمنيش فيه. الموضوع ده ما تكلمنيش فيه. انت كنت طالب هنا، والمعلومه دي انا مش اول مره اقولها على فكره. المعلومه دي لا، راجع كده الفيديوهات اللي انا قلتها، وحتى الحصص اللي انت قلت هنا. ما فيش حاجه اسمها take an arrow and answer in the back. لا حضرتك اسمعني بس، احلف لك بالله ان ما حدش هيشوف الاجابه اللي انت رسمتها بعد الايرو. يعني مثلا لو انا كتبت هنا for example انه the answer should be I1 or I node or IS written here. Let me share with you the projector. I node and IS. If you write this answer much below, like if you take an arrow and go down here and write the number here, no one will see it. I told you that before. It's just a scanner. The scanner will scan the question and the space is provided. بس اكتر من كده مفيش. الكلام ده انا قلته اكتر من مره. هتيجي بقى تقول لي اشتكي ما اشتكيهوش. انت لما سالت واحد كان واقف عليك، الراجل ده راجل غلبان، جاي يقف هنا عشان يخلص الوقت ويروح. هو فكرته ان الامتحانات دي or this exams will be corrected physically. ده ما بيحصلش الا في الاي بي يا حبيب قلبي. خلاص؟ ما فيش اي اكزام في كامبريدج بيتصحح فيزيكالي زي ما بنعمل في المدارس. وتزعل ما تزعلش، يبقى بعد كده الكلام اللي نقوله يمشي. الله. هو من امتى احنا بنعتمد على سؤال الانفيجيليتور واقف عليا قد يكون ما يعرفش الرولز في كامبريدج؟ لان انا بقول لك دلوقتي ما فيش اي اكزامينر بيمسك بيبر يا حبيب قلبي.
هو كان لابس هو يعني نو، يعني هو جاي نو.
وكل دول بروتال بريتش كاونسل، كل دول بتوع البريتش كاونسل. ما فيش الكلام ده يا بابا، ما فيش الكلام ده.
المفروض اعمل ايه يعني؟ يعني قلت لك كام النهارده في الباي دي درجتين، يعني عاملهم. قلت له عامل بالقلم، قال لي سالته تاني قال لي اعمل تحت الكويشن بالقلم.
من باب اولى كنت تسال المدرس بتاعك الباي.
طب يعني اروح اعمل ايه؟
انا ما اعرفش والله ما اعرفش. انا هقول لك الحقيقه، انا هكذب عليك. انا بقول لك الحقيقه، ما تضيعش وقتنا اكتر من كده. الله يستر. بص للي جاي بقى خلاص. نعم.
يعني لو انا عملت زي لاين كده مفيش مكان عند.
Imagine انه even this, if there is no space, I told you before what to do. والله I told you before what you have to do. انه even if you cross it out, make your handwriting smaller and write in between the lines. بس تكتب انه the answer in the back or the answer is down, no one will see it. مفيش الكلام ده. ارجع لدي. وأنا ظني إنه when I share some paper, I show you that before and I highlighted before in one video before and in one class before. I said, write your answer in each question in the space provided. احنا الاكزامينرز اللي انت بتقول شفتهم دول ما عندهمش وقت خالص ان هم يضيعوا وقت ويكتبوا كلام ملوش لازمه. رايت؟ فهو اساسا مش من حقك انك تسال اي انفيجيليتور، وانا لو براقب على اي لجنه وحد سالني سؤال هقول له ماليش دعوه. يعني انا لو واقف على لجنه دلوقتي براقب على اولاد بيمتحنوا والله هقول له ماليش دعوه، وانا مالي يا عم. انما هفتي ما بفتيش انا. ناقص كمان نروح للبراكتيكال، مستر كان اي يوز ذس رولر، بس هو انا راسم لك رولر على السكيل. هقول لك you can use this rule. If it was right or wrong, this is not responsible. هو مش هيخسر حاجه. يا سيد الفاضل، الناس اللي بيجوا يراقبوا دول مجرد موظفين، احنا جايبينهم عشان يراقب وهياخد قرشين على كل ساعه هيوقفها. ادي الموضوع من اوله لاخره. الكلام خلص لحد كده، لكن ده ما بياخدش كورس تدريب مثلا. البريتش كونسل السنه دي ملوش علاقه بالامتحانات. هتقعد بقى تتكلم كلام كبير انت مش. البريتش كونسل السنه دي ملوش علاقه بالامتحانات. Yes.
Now, Mr. Our next physics exam is next week, so we will take physics classes only in Monday and Wednesday.
Why not Sunday even?
قصدي Sunday and Wednesday. قصدي ما حناخد extra classes.
For paper 4, I think no. When the exam is it Wednesday? طيب ما هيبقى عندنا Sunday and Monday, and also we can take a class on Tuesday. No problem. But it depends on you. If you request that, we can.
Yeah, okay.
Right. No problem. But again, I read that before. In all papers except paper 2, because you have an answer sheet, right? In paper 3 and paper 6, you need to answer each question in the space provided, because simply when we cut the paper, we're going to send this part in the examiner, this part only. So if you take an arrow like this way, the answer is down. I need to see it, but actually it's not in front of me in the image, so I cannot award the mark. Right? I said that before. يلا بينا. عموما اللي فات وما تشغلش بالك، ما تسالش حد قبل كده بعد كده، ما تسالش حد بعد كده. في instructions in the beginning of each exam. Please read it and understand it. Don't write in any barcodes. Said that before. If you write in this barcode, your information could be hidden, so no one could read it. It will not affect your mark, but it will affect the date of releasing your results. So it could take some time to know who you are. Then you may use a calculator. It's allowed for paper 2 and paper 4 and paper 6 to use a calculator, unless if your mental math is fine, so you couldn't use it in paper 2. It will save your time if you don't use the calculator. Then you should show all your working and use appropriate units. The word should here, it means you have to. And sometimes we could just cancel some marks because of the unit is not correct. So you need to write the units beside each question. And this is the difference between O-level and AS. In AS, we will write the unit for you, but in O-level, you need to write the unit yourself. The information, the total mark for this paper is 40, and the load is just 20%. So depending on that, it could be 40 out of 200 by the end of the story, and it could be 30 out of 160, right? So when it comes to 30 out of 160, so we're going to correct it and change the mark from 40 to 30 to make it just 20%. In both these cases, is just 20%. And this is the lowest load for any paper. Paper 4, it could be out of 50%, and paper 2, it could be out of 30%. And paper 6 is 20, just 20. It doesn't mean that it's not important. It is important, because 20% it means 1/5 of the mark. Yalla bin. Question 1. Student investigates the extension of spring and uses it to determine the weight of a meter rule. So the spring is shown full size in figure 1.1 and figure 1.2. So this is the figure to your left hand before hanging the ruler, and that is the position if you hang the ruler, so it will extend as you see here. Then figure 1.1, measure the length L node. Make sure that when you measure the length L node, you put the ruler and this 2 lines, and the ruler should be exactly vertical. يلا حبيبي.
2.0.
شيل دي بقى عشان اسمعك. يلا شيل دي عشان اسمعك. 2. Just to confirm, is it 2?
2.0.
Okay, I'm gonna write, if you write 2, we said that it could be wrong because we don't have this kind of rulers, and this mark will be cancelled. So you need to write it 2.0 if it was exactly 2. Then on figure 1.2, measure the stretched length LS of the spring. What do you think?
Zero, I got 6.2.
Okay, 6.2. So I'm gonna write here 6.2, and the measuring unit is centimeter, as you know. But if you write 6 only, it could be a mistake, but even in 2 here, this is the mistake that I told you about the measurements. This is wrong and this is correct. So there is a big difference between them. Okay, fine. The next reading, or the next part of the question is, just a minute. على فكرة the class is now on live، فأنا مش عايز أدخل تهريج في الموضوع، خلاص؟ بس عموما الكلام اللي أنا قلته لو أنت ما سمعتوش أول مرة ما فيش داعي إن أنا أقوله تاني. الموضوع خلص خلاص. ماشي الحال؟ كلمة أكيد مش أكيد وبتاع، راجع الفيديوهات اللي أنا قبل كده والحصص اللي أنت حضرتها أو ما حضرتهاش، راجع الكلام ده. بس. يعني زي ما بيقولوا يعني قل هل يستوي الذين يعملون والذين لا يعلمون. الموضوع ما طيب. That was LS. Your copy is here, so once when it's finished you can take it. يلا بينا يا أولاد. B. The students attached a meter rule to a spring with a wire hook as shown in figure 1.3. The scale of the meter rule faces upward, so the scale is down. This is a very important word. We said she ensure that the meter is horizontal. Briefly describe how to check that the rule is horizontal. You may draw a diagram if it could help you in your explanation. Listen, to make sure that the line or the ruler or whatever the bar is horizontal, we have a reference. The reference is the bench in the lab, right? So this is the bench over here. It's written here. This is the bench. So we need to make sure that the distance from the bench to the ruler in one point should equal the same distance from the bench to the ruler in another point. A triangular ruler. Anyway, let me see that after the class. But the drawing here, if this is the ruler, right? And I'm gonna draw just a figure for the bench here. It's wider. This is just a caricature. This is the bench, and here we have the ruler. I'm gonna just take this measurement. I'm gonna give it a distance. A symbol like D1, and another distance here like D2. And in my explanation, I'm gonna share that. Make sure that D1 equal to D2. Because our reference here is the bench, itself, and the bench is supposed to be horizontal. So if the ruler was parallel to the bench, it means the ruler also is horizontal. You got the paper? اعمل لنا بقى الميجرمنتس when I ask you to do so. And it was 1 mark. This figure and this explanation is more than enough for this question. Let's go. The distance moves load W to distance D equal 20 centimeter, D equal 30 centimeter, then D equal 40 centimeter, D is 50 centimeter, and finally 6 centimeter from the pivot. She records the length L of the spring for each load, for each value of D, and her readings are shown in the table. When D is 20, so L is 6.2. When D increased, so L also increased because of the increasing in extension. Then D 50, then the extension or the length, the length becomes 8.3, then 60 as a D, so the length becomes 9 centimeter. Yes, they said here, using the value for the table 1.1, plot a graph of L in y-axis against D, measured in centimeter in x-axis, and start the axis at the original point. So here we have 2 points. The first one regarding to x and y. So here is the 3 points that you need to care about, right? The first point is we need to start from the original point, and we need to put L measured in x and y axis. So L measured in centimeter, this is in y axis, and D here measured in centimeter, this is in x axis. This is what I have done. And we need to start from the original point, or the origin point, which is 0, 0. So let's take L, for example. The minimum L that I have is 6.2 and the maximum is 9. So I'm going to start here like 1, 2, 3, 4. So I will start with 0, then 2, then 4, then 6, then 8, then 10. This is perfect. So the minimum is 6.2 and the maximum is 9. And you need to start from the origin as they ask you to do. So this is what we could have here. For D in y-axis, we need to say yes. Why not? The minimum is 6.2. So why should I start? By what should I start? Give me a suggestion. Okay, let's do it. Let's do it. So the first point is 0, then 6, then what else? لا. If you start from 0 and 6, it means the next point is 12. This is one of the rules, Bardu, but you were busy. And no, the difference between 2 successive divisions should be the same. Leno 0, after 0, if it was 6, so after 6 should be 12. Now we start from 0, so after 0, if we have 2, so after 2, we have 4. Right? Then the same in D and y-axis. So I'm going to start from 20 is my minimum and 60 is the maximum. So 1, 2, 3, 4, 5, 6. So I'm going to start from 10, then 20, then 30, then 40, then 50, then 60. This is perfect. Now let's point a point. The first point is 20 and 6.2. So 20 and 6.2 are going to go there. So this is 20 and here is 6. Then here we have 6.2. It's somewhere here. So this is the first line. Which line? Let me see the point first. Right? So this is the location of 6.2 because you know here we have 7. So each division represents 0.2. Each division represents 0.2. So 6.2, it's the same location that I just did. The second point is 30 and 7.1. So I'm going to go 30, then 7.1. So 7.1 somewhere here. So I'm gonna put my small circle around it. Then the next point is 40 and 7.6. So I'm gonna go 40 and 7.6, 40 and 7.6. So this is 40, and here we have 7. 2, 4, 6. It's supposed to be somewhere here.
مستر هو مش كده استعملنا الحتة من الجراف قليلة؟
Yes, but you know why? I didn't
Because
read this paper. You
we had
just
to
shared
start
it.
from the origin.
No. I don't say that. They ask you, or they request you to draw the graph like that because they will ask you. I'm just guessing. They will ask you to continue the graph until you met the y-axis, and they will ask about the point which the graph crash y-axis, which is y-intercept. I think I'm not sure. I didn't see that before. But let's see. After 40, we have 50 and 8.3. يلا كده. So 50 and 8.3. So here we have 8.2 and 8.3. It's supposed to be somewhere here. Then 60 and 9. 60 and 9. It's supposed to be somewhere. Okay, I've done. This is the points of the graph. Then from the graph, determine L, the value of L when D equals 0. This is what I said. Yes, this is y-intercept, right? That's why they shift the graph up to the right. So you have a space down to the left to find y-intercept, right? Now you can extend your graph and make it thin as possible, as we said. I think this is my graph. How it looks like. It's passing among most of the points. Let's see. Let's see. There is a range should be in the marking scheme. I didn't check yet, but let's see what we will have here. I did draw the graph. Then if you go down L here, this is 4.2, 4.4, 4.6, 4.8. So this is, for me, it's 4.7. I could write that down here. It's 4.7 for myself. Yes, I did. Yeah, you're right. I did. I start from 0, 0. سيف حبيب قلبي، احنا ما عادش وقت. قول لي على سؤال اللي بيدور في دماغك مهما كان عشان انا اجاوبك. يبقى قول. ايه انت بتقول؟ بس في الكويشن بيقول we have to start from 0.0. So yes. Which point? As I said, from your graph, determine L, اللي هي the value of L small when D is 0, 0. Yes, go to D is 0.0 centimeter. 0.0. It's not a point. 0.0. This is the length. So where is the point where here D is 0.0? خليك معايا بقى. It's that point. So what's the reading here? It's 0.0. It's nothing. So the value of D here is 0.0. So what's the value of L? So at 0.0, go to L. Yes, this is the point that they ask in the graph. Let me ask you another question from your graph. Determine L when D is 20. Safe. Determine L when D equal to 15. Try. Seems for me it's below 6. Yeah, it depends on the slope of the graph. We will check the marking scheme later. Okay, so this is what we have done. Guys, can I ask you a question like about the measuring unit we just said? L equal 4.7. What's the measuring unit here? It's the same measuring unit for y-axis. Y-axis, the measuring unit is centimeter. So I need to write that down here, which is centimeter. خلاص, that was for this question. Let's go beyond. Calculate WR, the weight of the meter rule, using your value of L from CII, the values of L node and LS from A, and the equation. I'm going to use this equation like the K has been given. So equal to 2 times L minus L node. L capital here is 4.7 minus L node. I think it was 2. Is it? Yeah, L node is L small node. It's 2.0. Then divided by LS. What was LS? Sorry? 6.2 minus L node still 2.0. Then times K is 1.0. When you write this calculation, please respect the brackets. You need to put the brackets. It's very important. هيطلع كام بقى؟ أحمد بيه. $1.3. So I'm going to write here 1.3. Okay. Find the measuring unit. Think about it. لا هي مش كده, هي مش جسم. قول يا ريت. Okay, use it. Use it. Use it. Yes, use it. 1.3. What's the measuring unit here? يعني take it one by one. Let's see. L minus L node. What's the measuring unit for this part? Sorry? Centimeter. Thank you. And LS minus L node. What's the measuring unit for this part? Centimeter. And K, what's the measuring unit? It's written Newton. So this centimeter will cancel this centimeter. So what's the final measuring unit? Newton. It's that simple. أنا ما حفظتش حاجة. خلاص. So I'm gonna write here Newton. It's sometimes difficult to position the load W on the scale of the meter rule at the correct distance D from the pivot. So just one change to the average to overcome this difficulty. We could use that. No, we use a pointer or find the readings in the side of the load, then take the average, right? We could use that. One change to the average. I'm going to add here. This is the apparatus. I'm going to add a pointer over the load. So we have a pointer here. This pointer will guide you exactly what's the exact reading in the middle of the load, right? So I'm going to write here, use a pointer over the load. Use a pointer over the load. Yeah, it's just one mark. They didn't ask you to do some drawing or draw something. It's just one mark. Right. Double I, they said, so just one possible source of inaccuracy other than the difficulty described in DI, something that the experiment is carried out carefully. Parallax error, it's a general, yeah, but let's say something more specific. It is right. But in sometimes, guys, when you do this experiment, this is exactly horizontal, but the spring itself it's not vertical. So when you measure the height should be vertical, but the spring is not vertical, so this is not the real height. So I'm going to write that down here. This is something common in this experiment. I'm going to write that down here. You know, and sometimes the spring is not vertical. This is a sources of one source of the mistakes that we could have in this experiment. That was the end of the question, and we got 11 marks for this question. Let's go to question 2. Question 2 about thermal physics. Let's see. Students investigate the thermal insulation properties of air. He places a thermometer in a clamp. As you see here, we have a clamp and thermometer hanging net over the bench, over the stand. And they enlarge the part that we could use to make the readings. So record the room temperature theta R shown in the thermometer in figure 2.1. Let's see that. Theta R is, what's the reading here? Yes, Adam. We started that our class today.
23 degrees Celsius.
Yeah, I'm going to write 23 degrees Celsius. So just a reminder, this is 23 degrees Celsius. I got degrees Celsius from the scale. It's supposed to be this here. Thermometer. It's the common one. It's not written, but anyway, it cannot be Fahrenheit. It cannot be centigrade. It cannot be Kelvin. It's 23 degrees Celsius. This is the right answer. If you write 23.0 degrees Celsius, you will lose this one because this reading is not available in this game, right? So the students uses the average shown in figure 2.1, figure 2.2, and figure 2.3 to investigate the thermal properties of air. Let's see. Here we have a beaker B inside a container contains air gap, and here we have a beaker A without any outside container or air gap. So it's just exposed to air over the bench. Let's see what we have here. Beaker A and B are made of glass. Beaker A is placed inside beaker B. So the second part of the experiment, beaker A is placed inside beaker B. Fine. Inside beaker B. Okay, beaker A. B is inside beaker. Sorry, beaker A is inside beaker B for the second part of the experiment, as shown in figure 2.1. So in the first experiment, in the first part, we put it without container. In the second part, we put it inside that container, which is beaker B. The student removes the lid from beaker A. He pours 150 centimeter cube of hot water into a beaker A, or into beaker A, and replaces the lid. He inserts the thermometer into the hot water and records the temperature theta at time t equals 0. And then every 30 seconds, as you know, describe 2 precautions that can be taken to ensure that the temperature reading is as accurate as possible. Readings the temperature, or many papers before. What, number
Avoid
1?
parallax error.
Yes, take a lock perpendicular to the scale. Avoid parallax error. What else? Use? It cannot help for the reading. It is fine for the accuracy, but it cannot help for the reading. For the reading, we have 2 main reasons. The first one is avoid parallax error. We can write take a lock perpendicular to the scale. This is one. The second one, we're gonna write
Make sure it's not holding touching the
stir
glass.
the liquid or stir the water all the time, because in sometimes part of the water becomes hot and the other part still cold. So to make sure that the temperature is homogeneous. So I'm gonna write that down here. View the divisions perpendicularly. So I'm gonna write avoid parallax error. No, ما فيش screen to the scale. Yes, to the scale. you can
بس ده
see
ينفع أقول إنه
at the scale by 90 degrees. This is also have the same meaning. نعم يا علي.
yesterday you said avoid the temperature from touching the beaker. دي صح ولا لأ؟
Yes. This is not for the right reading. It's for the accuracy of the experiment, مش for reading. And they said here, is it reading as accurate as possible? Yes, we can write it. I'm gonna write it here now. So make sure. No. Repetition مش هيديك accurate reading. Accurate results, but not accurate reading. إن أنت قريت صح. So make sure that the thermometer not in touch with the glass. This is also correct. And we can say still stir the water, but 2 more than enough for the 2 marks. Which one? No. Whole paper 6 are the same. This is the first time for me to see it, even. This is 22 February, March. I didn't see it before. بس ممكن نروح واحنا عارفين الاسئله ونكتب في اماكن ثانيه ونخسر درجات برضه. ما هو انت فاهم بقى. Anyway. تقلقش ان شاء الله خير. Double I. The sense pushes away the water from beaker A. He then places beaker A inside beaker B so that there is an air gap between the 2 beakers, as shown in figure 2.3. He repeats the procedure described in BI. His readings are shown in table 2.1. So this is the table. 0.1 beaker A, the losing or the decreasing in temperature are shown for each 30 seconds, and the same for beaker A inside beaker B. So beaker A outside and beaker A inside beaker B, and here is the results. So write a conclusion. Remember, the idea of conclusion here, you need to take a look for the results in the table.
The difference.
By reference to the values, yes. So I'm gonna write here, it's so clear, we start from the same initial temperature, but we end up with, beaker A has lower temperature, much lower temperature comparing by beaker A when it was inside beaker B, right? So I'm gonna write that down here. And my conclusion is beaker A has much, we can write higher rate, as much higher rate of cooling comparing by beaker A inside B, right? And I'm gonna say that before your question, change in temperature in beaker A equal to, I'm gonna say the 85 minus 67.5, while change in temperature for beaker A at B equal to 85.5 minus 79. So this is 18.5, I think. And the other
17.5. على واحدة 17.
17.5, and the other one? It's just 6.5.
6.5.
6.5 degrees Celsius, and here we have Degrees Celsius. So the rate in case of A without beaker B, it's much higher because the decreasing in temperature is much higher. سؤالك بقى نعم. It's not more time, all of them. Yeah, you said it takes more time for the temperature to decrease in beaker A inside beaker B. Okay. The idea of rate here, it's related to the time. Rate, it means higher rate, it means faster. You said slower, it's the same. Students suggest that glass is a thermal insulator. Yes. Yeah. They say yes, students suggest that glass is a thermal insulator, and the experiment does not just test the effect of the air gap. So just one change to the average that would test the air gap more effectively. Make beaker B wider. Make beaker B wider. This is some point we could add it, because they said here, the glass B, it could be act as an insulator. So the rate of cooling will be less, right? So there is no heat energy allowed easily to go outside. That's why they said in the glass maybe act as an insulator. So if you want to make the experiment more fair, we could use beaker B much wider.
Mister, we can change the material of the beaker.
Or
Use a
we can
metal-
change the
metal
material of the
beaker.
beaker, and instead of glass, use another material which is not heat insulated. Or metallic container. Metallic container we can use, or thinner glass, or use a container of a thermal conductor like a metallic container. Yes,
Mister, can use a metal beaker.
A metal beaker, yes, or metallic beaker. So we're going to write here many points, like use a wider one to make the glass away. Number two, use a metallic beaker. Any one of them. Remember, this is all. Another student repeats this experiment using the same approach shown in figure 2.1, figure 2.2, and figure 2.3. State two variables that she should control in order to obtain readings as close as possible to the readings in table 2.1. It means, yes, it means something should be stays constant during the experiment. Time interval, the initial temperature. وانت بتشبه على الاجابه مش start temperature, اسمها initial temperature. Initial temperature and time interval. What else? Sorry? Amount of beaker. I didn't get that. Amount of water, you mean? Yes, the initial amount of water, or the amount of water. We can write many things here, like the initial temperature should stay constant. One more thing we can write, instead of initial temperature, we can write, in addition to that, the amount of water. It should be the same amount of water. And also you can add the time interval should be stays constant. But I don't like to write the time interval because it's just a ratio, Calculate the average cooling rate R for beaker A cooling on its own. Use the reading for beaker A in table 2.1 and the equation. Let's see. R is equal to theta node is 85.0, 85.0 minus 67.5 divided by T. What's T? 180 seconds. We did that before. So equal to, could you please calculate it? 0.0972. You know, I could write here 3 sig fig or 2 sig fig. So you can write this is correct, and also you can write 0.097. This is also correct, but not less than that, because it depends on the accuracy. So I'm going to write here the rate. R here is the average cooling rate, or the rate of cooling. It means I'm going to write 0.0972. Could you please let me know what's the measuring unit here? يا ابني اهدى، ادي لنفسك فرصه تفكر. انا لما سالت السؤال انا ما اعرفش الاجابه اصلا، بس انا بسال عشان نفكر مع بعض. يلا حبيب قلبي. What's the measuring unit for this R?
Degrees Celsius per
Sorry?
second.
ما هو لنفس الفكره وبنفس المبدا اللي عملناه هنا. When I say temperature minus temperature, so the measuring unit could be in degrees Celsius. And the time here is measured in seconds. So it is degrees Celsius backslash seconds, or degrees Celsius per second. It's that simple, wallah. So I'm going to write it's degrees Celsius per second. Okay. Even they said this is the rate of cooling. That was question number 2. Question 3. I'm going to say it loudly and clearly. The blank page, it gives you some benefit to do some rubbish work. Sorry for this concept, but it is rubbish work. No one will see it. No one will correct it for you. It's just for rubbish work. أنا ماليش دعوة باللي وصل لك. خلاص؟ نعم. ما بصحى النهارده ايه ده؟ ده انتوا كنتوا مع بعض صح؟ كنتوا مع بعض وسالتوا نفس اللي انتم مسمينه. لا ده مش اكزامنر يا حبيبي. اللي واقف عليك ده مدرس تربيه فنيه مثلا. والله، او ممكن يكون مدرس بي اي. ملوش علاقه بالفيزيكس خالص. والله ده واحد يراقب بس، واقف عشان لو انت غشيت يطلعك بره، بس اكتر من كده مفيش. وهتلاقي نفس نعم. انا بتكلم على الساينسز والله اللي يخصني. انا بتكلم على الساينسز، ماليش دعوه. انا بقول لك بتكلم على الساينسز، هي نفس الرول. احنا لما بنيجي نصح الورق ده ما بنشوفوش، ما بيتعملوش سكان. وانا قلت الكلام ده اكتر من مره. بيتعمل سكان على مكنه زي دي، تطلع كل كويشن بالسبيس بتاعته بس. يعني الاكزامينر بيشوف الجزئيه دي بس. خليني اظبطها لكم على السكرين. بيشوف الجزئيه دي بس خلاص. لا ولا اللي تحتها خلاص. ما لا خالص خلص. هو بيشوف دي بس. Then what you have to do is, or what he has to do is, there is a checkbox here. When I press it, I said that many times. When I press it, there is a longer box will be allow the examiner to award 1 or 2 or 0 or not applicable. Not applicable, it means the answer is not solved. سبته فاضي. خلاص. 1 it means you got 50% of the mark. 2 you got the full mark. 0 you solve it wrong. بس مفيش اوبشنز. لا في نصاص زي ما بنعمل في بعض this is wrong. مفيش نصاص، مفيش نص. وانا قلت الكلام ده اكتر من مره. بس انا هشوف دي. To be able to correct the next question, I have to flip the page. When I flip the page by pressing next, خلاص, this mark by its mark will be cancelled from my system. خلاص. So if you go to the second page and I observe and you wrote something here related to question E, خلاص, I awarded the mark already. هيمصمص شفايفه بس هيقول لك يا خساره. والله لا انا بص على فكره انا مش بهزر. احنا قلنا الكلام ده بس انت حضرتك لما جيت متاخر ما لحقتش انه احنا بنشوف الرولز دي. This point I highlighted many times انه write your answer to each question in the space provided. كلام واضح. ده ما يخليكش اسال لا واحد اسمه اكزامينر ولا حتى مدير الاكزامينريين. ما فيش الكلام ده يا ابني. ثم ان ده مش اكزامينر ما تضحكش الناس علينا. ده اسمه انفيجيليتور. ده جاي يراقب بس عشان لو حضرتك تعبت يوديك الكلينيك. لو حضرتك لا قدر الله غشيت يطردك بره. بس اكتر من كده ما فيش. They are not examiners, they are invigilators. The examiners for correction, and this is the truth that I said. You don't have to ask any one of them. You just need to read the instructions. وقلنا الكلام ده 100 مرة. عموما look forward. البلانك بيج دي يا اولاد for your rubbish work. If you want to try something, to write something, to just remind yourself by something, this is for you. But it will not scan. It will not scan.
Mister, if you write in the question, you will continue the answer in the blank page. ده عادي ولا لا؟
لا. للمرة الأقل.
ده بس في الفيزيكس ولا في كل حاجة؟
في الساينسز.
اوكي.
في الساينسز answer in the space provided بس. answer in the space provided وخلاص. ما حدش يتكلم في الموضوع تاني، خلاص بقى. خلصنا خلاص. ما فيش حاجة اسمها answer in the back. خلاص الانسر in the back keep it in the back. هاخدها ازاي انا؟ هشوفها ازاي انا؟ ما بتعملوش سكان. الماشينز دي بتاخد وش بس. اللي هي البارتس دي بس. Even I'm not sure if I see the script itself, I cannot see it all. I see just the question and the space. Then once when I correct it, I'm gonna press next. When I press next, I couldn't back to the question again to modify the mark. خلاص خلصت. انا طبعا لو واقف براقب على الامتحانات والكلام ده قلته 100 مره، لو انا براقب على الامتحانات حتى في مدرستي انا هقول لك اوكي do whatever you want، لانه التيتشر بتاعك هياخد الورقه كامله. Then he could flip it up and down and see every single point. بس في كامبريدج ما فيش الكلام ده والله، ما فيش القصه دي. ما حدش بياخد ورق. لما يكون قاعد اكزامينر قاعد في استراليا هبعت له الورق ازاي؟ ما ببعتش ورق، انا ببعت له السوفت كابي بس اللي هي سلايدز. لا بيحتفظوا بيه 5 سنين. والله بتكلم بجد مش بهزر، 5 سنين. لانه في ال5 سنين لو حضرتك رفعت قضيه او بتاع، بس خد بالك. ارفع قضيه عادي. والله عادي. هتاخد درجاتك في حاله لو كانت الكلمه اللي احنا وي هايلايتد answer in the space provided مش موجوده، بس هي للاسف موجوده. هي بيقول لك دي لانها not written، بس الثانيه ما تتقالش لانها written. You supposed to read it. بقول لك ايه، تجيبها كده تجيبها كده، دي غلطتك انت. احنا قلنا الكلام ده اكتر من مره. انا مش عايز اضيع وقت اكتر من كده، خلينا نشوف question 3. ruler, pencil, sharp pencil and read it with me. For the people in YouTube, I'm not sure if you have ability to speak in your mic or not, but I want to make sure that you can hear my voice. Could you please send any message to just confirm that you are here? Because I'm not sure if you are here. Someone said hello. Could you just any message just to make sure that you can see that well, especially in my camera, it's out of battery, but you still see the screen, right? Okay, fine. Okay, fine. Thank you. No, I'm asking the people on YouTube, not in Zoom, because in Zoom I'm sure you can hear me, but in YouTube I'm not sure. They don't have ability to speak, but in Zoom you able to open your mic. طيب يلا يا باشمهندسين. خلينا نشوف in question 3 this students investigates the refraction of light by a transparent clock. طيب so the students ray trace sheet is shown full size in figure 3.1, right? And here is the figure. We have a mirror and we have a transparent location for that transparent clock, and we have some points as pins. This paragraph you need to read it. The students places the transparent clock A, B, C, D near the center of the ray trace sheet as indicated in figure 3.1. Draw a normal to point N extending above AB. Label the upper end of the normal with the letter L. Extend above AB. Label the upper end of the normal with letter L. Let's see that. So here is the normal, and I'll draw it above it and label the end of it L, right? Listen, if it was a mirror, you don't have to draw any part down. If it was a mirror, But once it's a transparent block, the normal should be passing the two mediums. Part of the normal in air and the other part should be in the other medium. عشان يبقى فيه ability to measure the angle. Here is some accuracy for myself, but please you draw it well. I'm not sure if I can modify this or not. Let me try. Yes. Okay, fine. This is how it's supposed to look like. ايوه فاهم خلاص انت بتسال ليه؟ انت خلاص ميجر ذا انجل. ايوه ما حدش يروح يا اولاد بكره غير جيومتري سيت وشارب بنسل ورولر. شارب بنسل it means 0.5 maximum. 0.5 كتير. لا ده مش مكتوب عليه، ده بيتبري يعني خد معاك شاربنر. بس انا بتكلم لو انت اخذت قلم اللي هو اسمه يبقى 0.5 ماكسيمم، ما تروحش ل 0.7 ولا 1. يعني بلاش الكلام ده. او شاربنر مع ال HP pencil. Anyway, let's continue. Draw a normal. We did. The sense draws the line EN as shown in figure 3.1. On figure 3.1, measure the angle theta 1 between the lines LN and EN. Okay. I mean, let's measure this angle. This angle, you need to draw it. This is theta 1. You need to measure it. حد معاه protractor زيادة? For me, because of the angle, you know, I can use it. عندك protractor؟ لازم تاخد geometry set، ما حدش ينسى يا ولاد. كام الانجل؟
15.
15. It seems right. It looks 15 for me. Okay. If it was 15 or 16, write it, whatever you have. Yes. Any line. And no. I'm going to draw a caricature to show you the position of the protractor for some of you. Like the protractor is supposed to be here. And here is the 0 point. Then you need to read that like here we have 10. Then here we have 20. So the reading here is 15. Right? This is the right position for the protractor. Clear? Let me erase it. I don't have protractor in this software. So when I measure it, it was 15 for myself. If it was something else for you, just write it. Remember, if I write 15, it could be correct. Degrees, this is correct. If you write 15.0, this is wrong. You will lose the mark. Why? Check your protractor. There is no divisions. Between 15 and 16, there is no divisions. So just write 15, 15.0, it could be wrong. Since places two pins P1 and P2 on the line EN as shown in figure 3.1. Measure the distance D between pins P1 and P2. Please do this measurements. Exactly 3? Not 3. Okay, if it was exactly 3 or whatever you have, just write it down here. It's 3.0. 3 only will be wrong because we don't have this kind of rulers, you know, just centimeters. Between 3 and 2 and between 3 and 4, we have divisions. We have millimeters. انت بتتأكد ولا ايه؟ أول مرة تشوف ماستر. I don't have a last term. So it's 3.0 if it was exactly 3. Yes, because we have millimeters. Even if you write 3.00, this is again wrong. Because this is Werner. It's not a ruler. ما حدش فينا بيمشي بفيرنر نفسه. لا يعني فيرنر بيعور لو مشيت بيه. والله بيعور. اوريك واحد بيضايق يعني لان هو في sharp points or sharp edges. That's not. So just whether the two pens are a suitable distance about for accurate rate tracing. Explain your answer. خلينا نشوف. I think they're supposed to be far away.
I think they're supposed to be at least 5 centimeters.
Oh yeah. So we could write that down without mentioning any number. I'm going to write that down here. And they're supposed to be far away. So I'm going to write here the statement. It's not suitable. So it's, I'll tell you. Because they are very close to each other. بص انت خدتش بالك من الفرق هنا P3 and P4 P2 and P1. Oh yeah. So this is what we said. Now the distance between P1 and P2 should be larger. So I'm going to write that down here. The explanation, the distance should be larger as possible. The distance should be larger for more accuracy. Okay, fine. That was the statement and the explanation. Let's see, the student places a plumb mirror on line CD, as you see in the figure, and views the image of pins P2 and P1 through the transparent block. She places two pins, P3 and P4, so that this pins and the image of pins P1 and P2 all appear exactly one behind the other. We read that before. On figure 3.1, draw a line, throw points P3, P4, and extend the line 3 centimeters below CD. Let's go. Draw a line, and they said P3, P4, right? Okay. P3, P4, and extend it below D3 by at least 3 centimeters. This is what I'm going to do right now. 3 centimeters down. Okay, seems for me more than 3 centimeters, but it's fine. This is what you need to do. It's supposed to be straight line. I got one more for this.
Is that exactly 3 centimeters under or more than 3 centimeters?
Just a minute. Yeah, no. They said here extend the line 3 centimeters below CD. It's, yeah, make it exactly 3 centimeters will be much better. Label the points at يعني broken line. لا بلاش بروكن، خليه ستريت لاين، اعمله برولر ستريت لاين برضه يعني. بيتصححوا على سكرين لان انا عندي ايبل ان انا افتح رولر. والله اوريك السوفت وير السوفت كابل اللي بنصحح عليه، بس I'm not sure because we are live. I'm not sure if I allowed to show you or not. بس الحقيقه في I can press a button, there is a ruler will appear and there is a protractor will appear. خلاص، لا الشغل ده ما فيهوش غلط. اسمع اللي بقول لك عليه. أنا بفهمك. لا, once when I press this button, there's a virtual ruler and a virtual protractor should appear. I can use them for measurements, and it gives me exactly the measurements that you did in your paper. محسوبة بالظبط. لا دي ما فيهاش غلط. Label the point at which this line meets AB with the letter G. AB with letter G. Let's see. Okay, so here we have a label which is G. We did. A, B, we label it. Fine.
Label the end of the line H.
Label the lower end of the line with the letter H. You know, after 3 centimeters, I'm going to label it with H, and that's it. D. The sense repeats the procedures for an angle θ2 equal 35. She places two pins P5 and P6 so that this pins and the image of pins P1 and P2 all appears exactly one behind the other. On figure 3.1, draw a line through points P5 and P6 and extend the line 3 centimeters below CD. Let's do that. So I'm going to extend between P5 and P6, and I need to extend it 3 centimeters below CD. Okay, we did. They said label the point at which this line meets AB with the letter R. So I'm going to go directly to that. And here we have R. Then label the lower end of this line with the letter S. So I'm going to do that S here. 3 centimeters below, then S. Label the point at which GH and RS crosses with a letter T. So here we have letter T. But fine. Why they ask you to do so? مش شغلك. قلنا دي أكتر من مرة ولا ما قلناش؟ مش شغلك ده حبيبي. اللي اتقال لك عليه اعمله وأنت ساكت. Then measure the angle beta, where beta is the angle between lines GT and RT. Let's go. GT and RT. GT, RT, this angle between GT and RT. Could you please measure it and tell me what's that angle? 17? Ahmed? What's that angle? Could you try?
18.
18. If it was 18 or 17, just write it. Don't write any points here. So I'm going to go through that option. I have it here, 17. So I'm going to write 17 degrees. If you have it 18 or 16, just write it as it is. Then we have a suggestion, and depending on that suggestion, you need to write your statement about the suggestion and the justification for your statement as usual. Like, since suggests that the angle beta should equal to theta s, where theta s is calculated using this equation, it's fine. Theta 2 minus theta 1. Let's see theta 2 minus theta 1. I got theta 1, but theta 2 is, sorry? Initial temperature. Frame theta 2. And the question. Okay, fine. I need to see it. Okay, theta 2 is 35 and theta 1 is 15. So I'm going to write 35 minus 15. So it's 35 minus 15 equal to 20 degrees. And theta, while theta is 17. Can we consider 17 equal to 20? I doubt. I have some doubt in this point. I'm not sure if could I write this suggestion correct or not.
مستر أنا فتحت المارك سكيم عشان أشوف الأنجل بتاع اللي فات. It was written 18 plus or minus 2. يعني 20 would be considered right مفروض يعني.
20 from 20 to 16 is correct. Yes. So this is what do you mean? بس واحنا بنحل مع بعض تبقى تفتح الماركينج سكيم بعد ما نخلص الحلقه، بعد ما نخلص الحصه دي. اوكي؟ تفتحش الماركينج سكيم دلوقتي عشان تلخبطك كده. بس anyway, according to what you just said here, it could be from 16 to 20 degrees. This is correct. Anyway, away from this point, I'm asking about the statement. What should I write? Theta is 17 and theta s is 20. Are they equal? Can we consider, the difference between them is can be ignored? هي مش رأي في rule.
We will see if it's more than 10% or less.
I'm gonna write here in the blank page. You can do this rubbish work like the difference in reading divided by the reading average times 100. Again, the difference in reading The difference in reading divided by reading average times 100. يلا بينا. What's the difference in reading? 3. 17. I got it 17 and it was 20 for theta s. So the difference is 3. Divided by the average between 17 and 20 is 18.5. So I'm going to write 18.5 here times 100. Could you tell me how many percent that we have? 16.2. 16.2%. It's more than 10%. So we cannot ignore the difference. So I'm going to write here my statement is no, because the difference between them, theta and theta s can not be ignored. If you got an 18 and the percentage was less than 10%, you can say yes, and the difference can be ignored, and both are correct.
Oh, I got 10.5. That's still more, no?
10.5, you have two options. If you write yes, you can write in the justification the difference can be ignored for the limit of the accuracy. If you write no, you can say the difference cannot be ignored because it's huge. It's up to you. And both are correct, believe me.
Okay.
And even if you open the marking scheme again, but don't, you will not write, you will not see any correct answer. They will ask, they will write a logical statement for a good reason, but there is no answers. They will not give you a final answer. And sometimes they can say expect, or we expecting the students to say yes or no, but it's just expectation. Now, yeah, yes, yeah. If the difference was big, so your answer in double I depending on I. So if I is wrong, so your answer in double I cannot be wrong because this is error character rule, right? Yeah. 18.5. if in 18.5 دي الافريج، احنا قلنا الافريج طبعا الريدنج الافريج اللي هي 17 بلس 20 divided by 2 تديني 18.5 مش كده ولا انا غلطان؟ Yeah, 18.5. 18.5. Oh yes, exactly. 17 plus 20. Where is it? 17 plus 20 gonna give you exactly divided by 2. It gives you exactly 18.5. Yes, precautions. So just 2 precautions to take in this type of experiment to ensure accurate results. Many things to say. Carry out the experiment in a dimmer room, or make sure that the pins are exactly vertical.
Make sure there's enough space between the pins.
Use very thin pencil when you draw lines. تمام؟ لا مفيش repetition. لا البركوشن مش repetition مش precaution. Repetition مش precaution. Precaution, this is something in the experiment itself. So I can write many things like, and make sure that the pins are vertical. Then here use very sharp pen or pencil or very sharp lines to detect the rays, because you know all these lines we consider them the thickness 0. We consider the thickness is 0. The last point is just one reason why different students all carrying out this experiment carefully may not obtain identical results. Sorry? No, it's not regarding to this, but we can write something like the thickness of the pencil or the thickness of the lines. Because the beginning of the line and the middle of the line and the end of the line, like if we have, imagine I have this line here, and I have another line like this. The reading here, if you take a closer look, here we have a reading, and here we have another reading. So this is R1 and this is R2. In the middle here we have R3, which is the average. So maybe you will take R1, the other students will take R2, and the other students will take R3. So it depends on one of the reasons if we can get different results if we have if we ignore the thickness of the pencil. So I'm going to write that down here, due to the thickness of the lines. So due to the thickness of the lines. And also we have a mirror here. We can write the thickness of the mirror. The thickness of the mirror itself also we consider it 0, but actually, to be honest, any mirror, it can't have thickness 0. Okay, that was, I think, the third question. Blank page. Yes, I think this is the last question. Fine, fine. You don't have what? You don't have this page? I didn't print it. I didn't print it, but it's عايزين يعني اطبع لكم blank page. خد ورقه خد بيج من دي واكتب عليها blank page. انتوا بتهزروا ولا بتتكلموا بجد؟ page 13 you mean. مالها؟ You don't have it? Sorry, this is my mistake. خلاص بس yes, have a blank page. It's just lines, you know. Okay. Forgot what we have, what we said right now. Forget it, because this is easy and it's memorized. If you solve 3 papers, خلاص, full mark. But regarding to this question, you need to think, because even you cannot depend on the marking scheme. Said here, a student investigates the heating of water using an immersion heater. Then an immersion heater is an electrical heater that can be immersed inside the water directly. You know, I know how it looks like. Yeah, for example, if this is a cup of water, just take a look. The heater, it could be, looks like a unit here. It's connected to the electricity directly, and there is a heating element, could be immersed inside the water, right? So this heater, it can help you to heat the water fast. Anyway, this is what we called immersion water or immersive heating element. So plan an experiment to investigate how one factor affects the rate at which the temperature of the water rises when heated using this kind of heater or immersion heater. So the idea is we are heating the water here, and this heating effect, it has a rate. It could be get hot fast or slow, faster or slower. It depends on some factors. You are free to choose whatever you want. Insulator, cap, whatever you want, right? I don't know, it's just one beaker enough. Then we're going to rate it. Let me explain that. The breaks available includes the immersion heater. So this is a heater, you can immerse it inside water, or you can put it deeply in the water. Equipment to connect the circuit, part of which is shown in figure 4.1. Where is figure 4.1? Oh yeah, so this is the heater, so we can continue the figure. And stop clock, we have a stopwatch, a beaker to contain the water. In your plan, you should state the one factor which you have chosen and list any additional approach needed to measure the factor. You know, which factor that we could that. I can see here a variable resistor, so we can depend on one factor like the current. I can increase the resistance or decrease it to increase the current or decrease it, right? If I increase the resistance here, so the current will decrease, so the heating element will get hot slower, and the water will get hot slower, and so on. So it depends on that, or the power will be less. The power consumed will be less, because you know, the power equal V times I. from our studies. So I'm going to choose this because it's already available. I will choose the effect of current on the heater or on the rate of heating for that water. This is one factor. So I'm going to write that down here. So the current or I, this is the factor that I will depend on. Complete the circuit diagram. We will complete the circuit diagram right now. Explain how to do the experiment. We will write it, including any precautions to ensure reliable results. What's the precautions here? The power supply or the EMF stays constant all the time. I will not change the battery. It's just the power supply. Then the amount of water should be stays constant. Same amount of water. I'm just reminding myself. And nothing else. State the key variables to be kept constant. This is what we just said. So draw a table or tables with column headings to show how to display the readings. You are not required to write any numbers in this table or any readings because simply there is no experiment. Explain how to use the readings to reach to the conclusion. The graph. When we draw a graph, I'm going to give you the conclusion. So just write down here. Let's continue the figure. I could say this is the power supply. Here we have. I can write here a voltmeter. I can draw a voltmeter here. This voltmeter could help you. I'm gonna draw it. Sorry, a meter. It's the same. So this ammeter will tell you an idea about the current in the circuit. Right. And I'm gonna close the circuit from here. Then I will apply a switch. So this is what makes it more accurate. So the power supply, it has its own EMF. No, it's okay, it's fine. Right? But this ammeter will guide you about the current, will tell you the reading of the current. Right? And no, the voltmeter cannot be connected seriously. It should be connected parallel, right? And the variable resistor here is R. I'm gonna give it a symbol R to make it easy for me when I explain it. That's it. We did the label and they draw for you. Let's start. Number one, set the tools as shown. So this is the best idea. And here I'm gonna put some amount of water here. So this is water at room temperature. Water at room temperature. Then also we have a stop clock or stopwatch. I need to write it down. Water at room temperature initially. Then I'm going to start. Set the tool as shown. Number two, measure the temperature of the water, which is initial temperature. And we need to start the experiment. Number three, switch on the circuit. Switch on the circuit. And take the reading of the ammeter. Number three, number four, record the temperature of the water after we could say 3.0 minutes. No, we cannot go like this, because in this case, you will take a factor of heating, which is the time. But right now, it's just the current. So I'm going to measure the temperature after 3 minutes directly, right? You'll understand it later. Because in the second step, we need to change the current and repeat the experiment again. Number 5. Yeah. No, before that, find the change in T, which is equal to T final minus T initial. Number 6, we need to repeat that again by using a new amount of water with the same initial temperature and with different current. So number 6, change the variable. We will write it. Yeah, some conditions should be set constant. We will write it. But they said change the variable resistor and record the new current and record the temperature of the water after 3 minutes. Just a little note here. We used new water, but same amount and same initial temperature. I wrote it 3 minutes. Initial temperature. Okay, fine. The same amount, same initial temperature. The repetition right now, I'm going to repeat number 7. I repeat 3, 4, 5, 6 until we have 6 sets of reading. This is the minimum number that allow you to draw a perfect graph. 6 sets of readings, yes. So I'm going to say here, repeat 3 up to 6 until you have 6 sets of readings. Number 8, arrange the data in a table. So here is the table. What do you think? What could be in the table here? The first one is the number of the trial. It's supposed to be 6. Then we have, it's not the time is fixed, so no need. I'm going to write here the change in temperature and the current measured in ampere, and the change in temperature measured in degrees Celsius. Right? Then number 9, draw a graph to get the conclusion or to have the results. This graph, it's supposed to be like that. Here again with the current measured in ampere and here is the temperature measured in degrees Celsius. And I think, you know, by increasing the current, the temperature will increase, but don't start from the original point, right? Because the temperature wasn't 0. So I will start my temperature, I start my graph from this point. لا ما هو العكس معناه انه the temperature in a certain current was 0. But right now the temperature is never 0 when even the current is switched off. Right? This is what I mean. You don't have even to draw the graph line. You just show the axis and that's it. You know, by looking, you could get the results. You know, by increasing the current, the temperature will, or the change in temperature will increase. So the change in temperature measured in degrees Celsius. It's not a temperature, it is the change in temperature. So make sure that you wrote here delta T. Delta T will change by changing I. We still need to put one point, which is number 10, during the experiment, what should we keep constant? The amount of water. What else? Initial temperature. What else? Same power supply. The power supply. All should stay constant. Right? This is what I have done, and I think by this way we wrote everything regarding to this experiment, and we explained if we are in the lab, what should we do in this experiment. Is it clear, Yasada? Are you sure? I have finished. If you have a question, please ask. If you don't have a question, you can leave. Thank you.
Mr.
قول رئيس.
Can before you delete it بس can you take a screenshot of it and send it on the group عشان ما لحقتش اكمله.
هبعت لكم الفايل كله PDF.
Okay, thank you.
ماشي.